Alright, so in the previous video we took a look at the various different kinds of air guns available, how each of them work, and the advantages and disadvantages of each. We singled out the pre-charged pneumatic as the kind of air gun that is best suited to precision shooting, and so today we're going to move all the other kinds of air guns aside and just focus on the PCP. We're going to look at all the internal mechanics in detail and discuss how each of these parts can influence accuracy, efficiency, and consistency. We're going to start off by dividing PCPs into three major categories. We've got unregulated mechanical PCPs, regulated mechanical PCPs, and electronic PCPs. Each of these different kinds of PCPs work slightly differently to each other, so we'll look at them one at a time. The unregulated mechanical PCP is the simplest of the three and probably the most common. It works something like this. Air is stored at high pressure in an air cylinder or bottle. When the rifle is cocked, a spring-loaded hammer is pulled back and held in place. When the trigger is pulled, the hammer is released and it slams into a valve which opens for a split second, releasing a puff of air from the cylinder, which then travels through a transfer port and into the barrel, propelling the pellet down the barrel. As soon as the hammer strikes the valve, pressure behind the valve, along with a valve return spring, cause the valve to close again. Now as you fire more and more shots, air in the cylinder is used up and the pressure drops. So it's natural to assume that as the pressure drops, the gun will lose power, correct? Well, actually, this isn't the case at all. A graph of pressure to velocity actually looks something like this. This is called a power curve, and pretty much all unregulated mechanical PCPs will have a power curve. Let's just take a look at three different points on the curve and analyze them a little bit. So at point A, we have a high cylinder pressure, but this extra pressure actually causes the valve to close faster. A hammer in a PCP will hit the valve with exactly the same force throughout the shot string, but the valve's resistance to the hammer will become less as the cylinder pressure drops. That means that at a higher pressure, the valve will be open for a very short amount of time, and at a lower pressure, the valve will be open for much longer. The balance between the pressure of the air released and the volume of the air released together is what adds up to give you your muzzle velocity. And obviously this balance isn't always perfect, which is why there is a curve and not a flat line. So the word unregulated basically means that the gun operates at a range of different pressures. This is called the working pressure of the gun, and this can vary depending on the gun. My Air Arms S510, for example, operates between about 190 and 150 bar, with the peak of the curve at about 170. My Daystate Wolverine, on the other hand, operates between 230 and 180 bar. It's quite a small pressure range if you think about it, but that's kind of a trademark of an unregulated gun. Now, interestingly enough, the advantage of a higher working pressure is that you can actually have a shorter barrel on the gun without losing power. Both of these rifles are shooting at about the same velocity, but the Wolverine has a much shorter barrel than the S510. Because the Wolverine's working pressure is higher, the pellet accelerates faster and therefore requires a shorter barrel length, whereas a rifle with a lower working pressure might require a few more inches of barrel length to accelerate to its top speed. A short barrel on a low working pressure gun set to a high power will waste air because the pellet may not have reached full velocity by the time it exits the muzzle. It will also cause the gun to sound much louder than it should. It's interesting stuff, isn't it? So you get the idea. Let's move on to the regulated mechanical PCPs. We've just been talking about working pressures, but what makes a regulated gun different is that it operates at the same working pressure throughout its shot string. In turn, this means that regulated guns generally have much flatter power curves than unregulated guns. As an example, here's a graph comparing the shot strings of two Air Arms S510s. The green line shows the gun without a regulator straight out of the factory, and the blue line shows the gun with a regulator. You'll see that the power curve is virtually non-existent on the blue line. The regulator itself is a little mechanical device that fits somewhere between the air cylinder and the valve. Its job is to ensure that the pressure on the valve side always remains the same, no matter what the pressure on the cylinder side is doing. It does this using little valves of its own. It basically lets in just enough air to get to the pressure it's set at, and then shuts so that the pressure is never exceeded. The only time that the regulated pressure changes is when the cylinder pressure drops below the regulated pressure, in which case the two equalize and drop at a uniform rate. When this happens, we say that the gun is off the regulator. A regulator does more than just increase consistency, however. It can also increase the shot count significantly. It doesn't cause the gun to use less air per shot, but what it does do is make the gun functional at higher pressures. An unregulated gun will have a maximum working pressure, and if you exceed that pressure, you'll get what's called valve lock. Basically, the pressure behind the valve becomes so strong that the hammer is no longer able to open it. With regulated guns, valve lock is not an issue, so you're able to fill the rifle to higher pressures. Now, the only limitation is the safe fill pressure of the gun. Some regulated guns are able to be filled to 300 bar and be shot down to 120. That is absolutely insane. Obviously though, the higher the fill pressure, the more you risk metal fatigue, blowing out O-rings, etc. So I wouldn't really recommend filling any gun past 250, even if the manufacturer says you can. The only reason that regulators aren't fitted in many PCPs is that they are fairly expensive, and they also require maintenance every now and again. A few years ago, you'd only find regulators in top-end rifles, but times are changing, and I've seen quite a few regulated entry-level PCPs pop up recently. Okay, and lastly, let's look at electronic guns. Here's an example of an electronic gun, the Daystate Pulsar. Remember how we were talking about hammers and valves earlier? Well, these guns work a little bit differently. Basically, there's a little computer on board the gun that reads the cylinder pressure. It then calculates exactly how long the valve needs to be open for to achieve a certain velocity, and then opens the valve for that calculated amount of time using a solenoid. What this means is that electronic guns will generally have much flatter power curves than unregulated mechanical guns. There's only so much magic you can work with a mechanical system, and the electronic valve just allows the gun to do a little bit more with the air that it has. Electronic guns can also offer some very practical features, like giving you the exact cylinder pressure or telling you how many shots you've taken since the previous airfill. These are obviously perks that you just won't get from a mechanical rifle. So let's bring this one to a close. Those are the three main kinds of PCPs and how they work. In the next video, we're kind of just going to continue from here and just cover a few very important topics such as PCP efficiency. We'll look at the theory behind power adjustments on a PCP and look at ways to get as many usable shots as possible out of your gun. Cheers for now. I'll see you in the next one.